Okay, let's look at this question. The lines L1 and L2 have equations of R1 equals to 320 plus lambda times 2 minus 31. This is the direction vector of the line. And line L2 have the equation of R2 is negative 4, 1, negative 3 plus mu times 1, 2, 4. So this is the direction vector of the line L2, where of course given as lambda and mu are parameters. Find the Cartesian equation of the plane containing the line L1, which is this line, as well as the point, which is 1, negative 3, negative 1. So how are we going to do it? We already know one of the vectors that is lying on the plane, which is basically the direction vector of the line, okay, because the question already says the plane contains a line L1, and we know one of the point that lies on the line, which is 320, as well as we have got another point here, which is 1, minus 3, minus 1. Since we have couple of points on the plane, we can also find the direction vector between this point and this point, and that would give us the another vector. And of course, if we take the cross product of this vector as well as this vector, we will be able to find the normal vector, and then it will be easier for us to move on to finding the Cartesian equation of the plane. So that's how we are going to do it. So first thing first, let's draw the plane in which we want to find the equation of this plane. So since the line L1 lies on this plane, the direction vector of the line L1, which is 2 minus 3 1, okay, which is here, okay, is pointing in this direction. And then we are given that this line passes through this point, right, 3 2 0. So let's say the origin is over here, xyz, okay, and from here, okay, we mark the position vector of the point A, which happens to lie on the line as well as on the plane, so which is 3 2 0. And we are told that this plane actually contains another point, okay, which is 1 minus 3 minus 1. Let's call this point as a point B, and let's mark that position of the point B, okay. So for this point, the position vector is 1 minus 3 minus 1. Now that we have 2 points, okay, A and B, I can find the vector AB. So how do we find the vector AB? Of course, AB is equals to the position vector of the endpoint minus the position vector of the start point. So the endpoint is B, so we're going to take the position vector of B, which is OB, and then we're going to subtract away the position vector of point A, which is OA. So what is the position vector of B? Okay, we already have it here, which is 1 minus 3 minus 1. So we're going to put that for OB, and then we're going to subtract away the position vector of the point A, which is simply 3 2 0. There we have it. And let us simplify or subtract. 1 minus 3 is going to give us minus 2. Minus 3 minus 2 is going to give us minus 5, and minus 1 minus 0 is going to give us simply minus 1. So the position vector, or the vector AB, okay, is minus 2, minus 5, minus 1. So now we have two vectors, okay, which are lying on the line. So how do we find the normal vector? Of course, we can take the cross product of AB and the direction vector of the line, and if we take the cross product between these two vectors, okay, we would end up getting the normal vector. So to do that, let us get the normal vector. Normal vector is basically going to be the vector AB cross with D. So the normal vector would be AB cross D. So what is AB? AB is, we have already worked out over here, which is negative 2, negative 5 and 1, and we're going to cross this with the direction vector of the line, which is 2 minus 3 1. So that's the direction vector of the line. Now we just perform the cross product between these two vectors. Of course, to find the I component, we can cover up the I, and so what we're going to have is minus 5 times a 1, which would be minus 5, and then minus away minus 1 times minus 3, which is of course going to become a plus 3. So we are going to have minus 5, okay, and then minus 3, which would give us minus 8. So that will be the I vector. And then the J vector, okay, we can skip that first and we go for the K vector. Minus 2 times minus 3, okay, is going to become positive 6. From that, if you minus away minus 5 times 2, which is going to become minus 10. So what we would have is 6 minus 10, which would become 6, plus 10, which would become 16, right? And 16 is the k vector component, all right? Now we want to go for j vector. Of course, you must remember to put a minus sign in front of the j vector before we perform the same kind of cross. Okay, we will cover j. Minus 2 times a 1 is going to give you a minus 2, and then minus away minus 1 times 2, which would of course become another minus 2. Minus of the minus 2 is going to become plus 2, right? And we will have a minus 2. Minus 2 plus 2 is going to give us 0, right? So if you put a minus sign in front of a 0, it's still 0, and that's why the j vector is a 0. So when we perform AB cross D, we should be able to get minus 8, 0, and 16. And let us simplify this, because minus 8 seems to be, I mean, every one of these numbers are multiples of 8. So I have chosen to take out negative 8. Of course, I am taking the normal vector in the opposite direction, but it doesn't really matter. So let me pull out the minus 8. So minus 8 times 1 is how you get a minus 8. Minus 8 times 0 is still 0. And minus 8 times minus 2 is going to give us positive 16. And so we have 1, 0, minus 2 as the normal vector. So we have the normal vector as 1, 0, minus 2. We can ignore this as scalar multiple of minus 8. So this is the simpler normal vector. So now we have the normal vector to the plane. Now we can start to find the Cartesian equation of the plane. So how are we going to do that? That's the normal vector. And then, okay, the vector equation will be of the form r dot n equal to a dot n. R is the general point, right? N is the normal vector. A is position vector of any point on the plane. Of course, we have got 3, 2, 0, or we can use 1, minus 3, 1. It doesn't really matter which one you're going to use. So r dot n, I am taking it from the first part, 1, 0, minus 2. And I'm going to multiply with a dot n. So for a, I'm going to just take that 3, 2, 0, since it is on the line and it contains all the positive numbers. So it's much easier. And multiply by the normal vector once again. This is 1, 0, minus 2. So there we have it. So now we can perform the dot product of the two vectors on the right hand side of the expression. And of course later we will replace the r with xyz. So 3 times 1, which is a 3, 2 times 0 is a 0, 0 times minus 2 is going to become another 0. So 3 plus 0 is going to give us 3 for the right hand side. So the r I am replacing it with the xyz. The normal vector I am just going to copy down as it is, 1, 0, minus 2. But the right hand side is of course simply going to become 3 plus a 0 plus a 0, which is simply going to become 3. Now let's now perform the dot product on the left, because the question wants us to write down the Cartesian equation. So 1 times x is of course x. Okay, y will disappear because y times 0 is going to become 0y, which is 0. So of course we don't need to write the y. And z times minus 2 is going to become minus 2z. And this is equals to 3. So there we have the Cartesian equation of this plane, which actually contains a line L1 as well as a point 1, minus 3, minus 1. So if you do it and write down this equation correctly, you will get 4 marks for this. Let us now look at part B. Part B says, show that the line L1 is perpendicular to the line L2. The direction vector of the line L1 is 2, minus 3, 1. The direction vector of the line L2 is 1, 2, 4, okay, which we can see here. These are the two direction vectors. And of course, if two lines are perpendicular to each other, the dot product of the two vectors should be equal to 0, right? If two lines are perpendicular to each other, the dot product of both their direction vectors should be equal to 0. So let's see whether these two dot products, when I dot product the d1 and d2, whether it gives us a 0, then we know that L1 is perpendicular to L2. So direction vectors, the product, dot product should be equal to 0. So what is my d1? d1 is 2, minus 3, 1 dot with the dot product of the second line, which is 1, 2, 4. So there we have it. So now let's simply perform the dot product. 2 times 1 is a 2. Minus 3 times 2 is going to give you a minus 6. 1 times 4 is going to give you a 4. So we have 2 minus 6 plus 4. 2 plus 4 is equals to 6. From 6 you subtract a 6, it's equals to 0. And therefore the two lines are perpendicular to each other, and we have shown it by showing that the dot products of the two direction vectors is equals to 0, and that should give us another 2 marks. Now let's go to the C part 1. We are told to find the value of lambda and mu such that R1 minus R2 is perpendicular to both line L1 and L2, and then we are told to find the position vector of the points where the common perpendicular meets the line L1 and L2. Okay, and if we can successfully do all of that, okay, we would get another 6 marks. So let's see how to do C part 1. Okay, R1 is given as this, right? So we could just simplify and write it down. So what we have, 3 plus lambda times 2, which is 2 lambda. So it's 3 plus 2 lambda, that would be the x component or the I component. 2 minus 3 lambda for the j, and 0 plus 1 lambda, which is simply lambda for the k. So that is our R1, because we need to find R1 minus R2. So that's why I'm expressing R1 in terms of its parameters, and I'm going to do the same thing with the R2 in terms of its parameters. So what would be R2? Minus 4 plus mu, 1 plus 2 mu for the j, and minus 3 plus 4 mu for the k. So minus 4 plus mu, 1 plus 2 mu, minus 3 plus 4 mu as we simplify the R2. Now we need to find out what is R1 minus R2, right? So this is my R1, this is my R2. So let's do the R1 minus R2. We're going to take 3 plus 2 lambda. From that, we're going to subtract minus 4 plus mu. So we know that 3 minus minus 4 is going to make it into a 7. So we're going to end up having for the I, 3 minus minus 4, 7 plus 2 lambda minus mu, because of the minus here, so it's going to become minus mu. And then for the j component is 2 minus 1, that will be a 1, minus 3 lambda minus 2 mu. And for the k component, it's going to be minus 3, which is a constant, and because of the minus sign in front, it's going to become minus of the minus 3, which would become 3 plus the lambda plus 4 mu. So when you simplify that, this is what you're going to end up getting. So 3 plus 3 minus minus 4, which is 7. Only the number changes. Of course, the 2 lambda is going to remain as it is, 3 lambda minus 3 lambda remain as it is, plus lambda remain as it is. Only for the mu parts, because of the minus sign, it's going to carry a negative or the opposite charge, opposite sign. So plus mu becomes a minus mu, plus 2 mu became a minus 2 mu, and plus 4 mu became a minus 4 mu. Then for the number, 3 minus minus 4 became a 7, 2 minus 1 it became a 1, and minus minus 3 became a positive 3. So there we have R1 minus R2. Now what we need to do, such that R1 minus R2 is perpendicular to each of these lines, right? To both L1 and L2. So if it is perpendicular to the line L1, of course, if we take the R1 minus R2 and we perform the dot product with the direction vector of the line 1, okay, which is what I call as a D1. Okay, since they are supposed to be perpendicular, the dot product should be equal to 0. So let's do R1 minus R2 dot D1 equal to 0. So this is our R2 minus R1, and similarly for L2 we can write down also. So R1 minus R2 times the direction vector of the second line, which is 1, 2, 4, should be equal to 0. So this is the R1 minus R2, and I'm going to multiply it or dot product it with, okay, 2 minus 3, 1, and it is equals to 0. And likewise, if we do for the other line, okay, it should also be the R1 minus R2 dot D2, which is 1, 2, 4, right, is equals to 0. Now if you perform the dot product and perform the simplification, you're going to get 2 times 7 plus 2 times 2 lambda minus 2 mu plus minus 3 times 1 minus 3 times minus 3 lambda minus 3 times minus 2 mu, and so forth. So we will be able to perform the dot product, and if you simplify that, okay, the dot product after you perform all the simplification, you will finally end up getting 14 plus 14 lambda mu would disappear, because you're going to have a minus 2 mu, and here you're going to have a plus 6 mu, and then you're going to have a minus 4 mu. So minus 2 mu plus minus 4 mu is going to become minus 6 mu. Then we're going to have a plus 6 mu from the j part. So minus 6 mu plus 6 mu would disappear, and therefore it would just have lambda, and there will not be any more mu. So you will have 14 plus 14 lambda is equal to 0. And likewise, if you simplify on the right hand side, okay, the lambda is going to disappear, only mu is going to hang around. So you're going to get 21 minus 21 mu is equals to 0. Now, of course, if you look at each of this, okay, equations, the only unknown is a lambda from this equation, and as you can see, lambda should be -1. And if you look at this, the only unknown is a mu. So 21 minus 21 mu equal to 0 means the mu should have the value of a 1. So lambda should be equal to -1 and mu should be equals to +1. So these are the values of lambda and mu, right? Find the values of lambda and mu. So lambda is -1 and mu is equal to 1. Okay, we have done that for the first part. Then it continues to say, state the position vectors of the points where the common perpendicular meets the line L1 and L2. What is a common perpendicular? Of course, the common perpendicular is R1, and R1 minus R2 is a common perpendicular. So this is my R1 and R2, and my lambda is -1 and my mu is 1, which we found from the earlier part. So we can now use that to find our R1. Okay, R1 is simply going to be, we're going to replace all the lambda with a -1, and then for R2 we're going to replace, you know, all the mu with a +1, right? And that's my R1 and R2. So of course we can simplify this. 3 minus 2, okay, 2, this would be a +3 minus 1, that would be my R1, right? So 3 minus 2 is going to be a 1, and then 2, okay, this part is going to be another +3. 2 plus 3 is a 5, and -1. And how about R2? R2 is -4 plus 1, of course, which is going to become -3. 1 plus 2 is going to become 3, and -3 plus 4 is going to give you a 1. So -3, 3, 1 is the value of your R2. So that is your state the position vectors of the points where the common perpendicular meets the lines L1 and L2. So you just find the position vector of the points R1 and R2, right? So find the length of this common perpendicular. So the length of the common perpendicular will be, substitute the lambda equal to -1 and mu equal to 1 into the common perpendicular, which was R1 minus R2, right? So R1 minus R2, just now when we expressed it in terms of lambda and mu, this is what we had. So we're going to replace the lambda with a -1 and mu with a 1, and we're going to find the vector R1 minus R2, and then we can look for the magnitude of the R1 minus R2. So let us do that. So I've replaced all the lambdas with a -1, as you can see, lambda is -1 and mu is equal to 1, so I can replace that, and then all we need to do is to just simplify. 7 minus 2 minus 1, and that's going to become 4. And then I've got a 1, -3 minus 1 is a +3, and this part is a -2. So 1 plus 3 is a 4, 4 minus 2 is going to give us 2. And then the k component is 3 minus 1, which is 2, 2 minus 4 is going to give you a -2. So there we have the vector R1 minus R2, which is a common perpendicular. Now we need to find what is the length. Okay, they are not asking what's the vector. Okay, and we need to find the length. That means we need to find the magnitude of this common perpendicular. So let's find the magnitude of this common perpendicular by using Pythagoras theorem. So we're going to take the square root of 4 squared plus 2 squared plus -2 squared. 4 squared is a 16, 2 squared is going to be a 4, so 16 plus 4 plus another 4, -2 squared is another 4. So 16 plus 4, 20, 20 plus 4 is going to become 24. So square root of 24, which of course is going to become, you can express it as a, break it up as a 4 times 6. So root 4 is going to give you a 2 times root 6 units. So that would be the length of this common perpendicular, and that's how you solve it in order to get your 2 marks.